Today we learned about solids. We saw that the solids are closely packed together. We also saw that they do not move past each other. They're stuck in place. They have a definite shape. The shape does not change. And they have a definite volume. The particles are very attracted to each other. That's why they stay closely packed together. The less attracted they are to each other, the farther apart they move. Let's check your understanding. How would you describe the arrangement of particles in a solid? They are packed closely together. Notice that in a liquid they get farther and in a gas even farther. How would you describe the motion of particles in a solid? They do not move past each other and they vibrate in place. Versus in a liquid, they start to be able to move past each other, and in a gas, even more. How would you describe the interaction of the particles in a solid? They are very attracted to each other. That's why they're so close together. In a liquid, they're less attracted to each other, so they go farther apart, and in a gas, they're the least attracted to each other, so they go the farthest apart. What will happen if I heat up the particles in a solid? They'll start to move faster and they'll get farther and farther apart. What will happen if I cool down the particles in a solid? They will get closer and closer together and vibrate even less. Now you may have noticed that neon, argon, and oxygen look very similar as solids, but water looks different. Water is an interesting substance, and it doesn't always behave the way that other substances do. Let's check out a cool experiment that shows if you heat up particles, they move farther and farther apart, and if you cool down particles, they get closer and closer together. This makes sense because we saw that if you heat up particles, they get farther apart and expand. And if you cool down particles, they get closer together. That's why the ball could fit through the ring when it was cold, but not when it was hot.